Hello, in this video I would like to show you the working principle of my small vacuum tube Tesla coil. First I am going to show it operating. The power consumption is around 16 watts with just the filament running and around 40 to 80 watts when it's operating. Now I am going to take a look at the circuit diagram. The upper part is the vacuum tube Tesla coil circuit itself. The power goes to this connector and it's fused using this fuse. That's 2.5 amp fuse. The inrush current when charging these capacitors is limited with an NTC thermistor. You can see it here. This circuit is a classic voltage doubler circuit, so I get around 600 volts peak when running from 230 volt mains. This part is the oscillator itself, the vacuum tube Tesla coil circuit itself. It's based on a PL 500 or 504 vacuum tube. This capacitor forms a resonant circuit with the primary coil, and here you can see several taps on the primary coil, so its inductance can be adjusted, and thus the frequency can be adjusted. Here is the resonant capacitor consisting of these three full capacitors and this small ceramic capacitor, giving around 370 picofarads total. It's wired as a classic Class C Armstrong oscillator. I don't think there's much to explain. The feedback is gotten from this auxiliary coil, which is placed under the primary coil. The second part is the filament power supply. I didn't have a 27 volt transformer on hand, or I didn't have a 27 transformer with reasonable size on hand, so I just used a 13 volt transformer and the voltage doubler, giving me around 28 volts with load. And the third part is a power regulating circuit. The mains input is halfway rectified, and then it's going to this voltage divider formed by this potentiometer and some resistors. When the voltage here, between here and ground, reaches around 160 volts, the neon lamps strike, and the voltage between the gate and source of this MOSFET rises, which turns it on. When the voltage drops, these lamps turn off, and the MOSFET also turns off. Its gate is discharged and protected by this resistor and this diode, and there is also a small snubber network. This circuit can be omitted, but if you want to regulate the power, it's good because otherwise the spark length isn't any longer and the tube overheats quite fast. The circuit ground is floating and it never should be connected to the mains ground. The entire device is placed on a Pertinox board, which is basically a phenolic resin board. It's uncovered, so it's quite unsafe actually. So I hope you liked that video.